The asteroid belt is the region of the solar system located roughly between the orbits of the planets Mars and Jupiter. It is occupied by numerous irregularly shaped bodies called asteroids, or minor planets. The asteroid belt region is also termed the main belt, to distinguish it from other concentrations of minor planets within the solar system. In general, in the solar system, planetary formation is thought to have occurred via a process comparable to the long-standing nebular hypothesis. A cloud of interstellar dust and gas collapsed under the influence of gravity to form a rotating disk of material that then further condensed to form the Sun and planets. During the first few million years of the solar system's history, an accretion process of sticky collisions caused the clumping of small particles, which gradually increased in size. Once the clumps reached sufficient mass, they could draw in other bodies through gravitational attraction and become planetesimals. This gravitational accretion led to the formation of the rocky planets and the gas giants. Planetesimals within the region which would become the asteroid belt were too strongly perturbed by Jupiter's gravity to form a planet. Instead, they continued to orbit the Sun, as before, while occasionally colliding. In regions where the average velocity of the collisions was too high, the shattering of planetesimals tended to dominate over accretion, preventing the formation of planet-sized bodies. Orbital resonances occurred where the orbital period of an object in the belt formed an integer fraction of the orbital period of Jupiter, perturbing the object into a different orbit. The region lying between the orbits of Mars and Jupiter contains many such orbital resonances. As Jupiter migrated inward following its formation, these resonances would have swept across the asteroid belt, dynamically exciting the region's population and increasing their velocities relative to each other. During the early history of the solar system, the asteroids melted to some degree, allowing elements within them to be partially or completely differentiated by mass. Some of the progenitor bodies may even have undergone periods of explosive volcanism and formed magma oceans. However, because of the relatively small size of the bodies, the period of melting was necessarily brief, compared to the much larger planets, and had generally ended about 4.5 billion years ago, in the first tens of millions years of formation. In August 2007, a study of zircon crystals in an Antarctic meteorite, believed to have originated from Forvestus, suggested that it, and by extension the rest of the asteroid belt, had formed rather quickly, within 10 million years of the solar system origin. There is the last dwarf planet on our list, and closest dwarf planet Earth, Ceres. Ceres has a diameter of about 950 kilometers, and is by far the largest and most massive body in the asteroid belt, and contains a third, 32%, of the belt's total mass. It sure is, and it doesn't stop there. There are hundreds more class of objects, so many that humanity will have its hands full for a few hundreds years trying to organize all of them. Well, it's how you define a solar system. Does it end at Pluto, or when the gravitational influence of the Sun ends? Of course I do. So is there anything else you would like to know? Well, if you think about it, space is so vast, and there are so many galaxies, and around those galaxies there are so many stars, and around those stars there is the potential of systems like ours. So yes, there are. If there aren't, I'd be amazed, and be greatly saddened.
Everybody lives on a street, in a city, or a village, or a town for what it's worth. And they're all inside a country which is part of a continent that sits upon a planet known as Earth. And the Earth is a ball full of oceans and some mountains which is out there spinning silently in space. And living on that Earth are the plants and the animals and also the entire human race. It's a great big universe and we're all really puny. We're just tiny little specks about the size of Mickey Rooney. It's big and black and icky and we are small and dinky. It's a big universe and we're not. And we're part of a vast interplanetary system stretching 700 billion miles long. With 9 planets and a sun, we think the Earth's the only one that has life on it, although we could be wrong. Across the interstellar voids are a billion asteroids, including meteors and Halley's Comet too. And there's over 50 moons floating out there like balloons in a panoramic trillion-mile view. And still it's all a speck amid 100 billion stars in a galaxy we call the Milky Way. It's 60,000 trillion miles from one end to the other, and still that's just a fraction of the way. 'Cause there's 100 billion galaxies that stretch across the sky, filled with constellations, planets, moons, and stars. And still the universe extends to a place that never ends, which is maybe just inside a little jar.
It's a great big universe, and we're all really puny. We're just tiny little specks about the size of Mickey Rooney. Though we don't know how we got here, we're important part here. It's a big universe, and it's all